Hi everyone, my name is Shivani Gupta. I'm an SE manager at EMC and I'm here to get Gen4 certified and talk to you all about all-flash arrays and why infrastructure matters. So in December of 2014, David Floyer of Wikibon wrote an article on the evolution of flash where he noted that flash drives in the last 7 to 8 years have followed Moore's law and doubled in capacity every 18 months. And have now reached an inflection point whereby early 2016 flash drives will be cheaper than fastest spinning media. What this really means is that flash will become a viable option for almost all workloads in a data center, and hence the need to look at all flash array architecture. So as Wikibon looked at the various offerings of all flash arrays in the marketplace, they categorized them in 4 generations. The first generation is where really the EMC is the pioneer in and launched flash back in 2008 in their flagship products of Emacs and VNX as cache or tier 0, and then saw the vendors like 3PAR, HP and NetApp follow suit. And what they really did was use software intelligence and algorithms to move data to these tiers based on I/O access patterns, and really helped to reduce or lower response times and really see improved performance for the overall system. This really still continues to be the most widespread use of flash. The second generation is really where we saw the arrival of hybrid arrays from startups like Tintri, Tejal, and Nimble. And what they really did was use a larger subset of flash drives with the flash first design to land the entire working set and then trickle it down to traditional storage media over time. This did not have any significant changes to architecture, but offered a simpler or easier software consumption model offered in a single appliance. But they cornered themselves into very few use cases where applications only with very small working sets could really leverage the benefits of these. So we call this the generation of insignificance. The third generation is what really saw the arrival of the all-flash arrays with vendors like Violin and Texas Memory Systems having offerings across, and using NAND as persistent storage media, but they really didn't have any offering for the enterprise data center, from a data services perspective. Then showed up Pure and Nimbus, which really did have some of these offerings, but sacrificed performance for these services. Customers had to choose between, or they were forced to choose between performance or efficiency. And in some cases, we noted when they wanted both, the performance was actually worse than their Gen 1 or Gen 2 counterparts. So we call this really the generation of compromise. The fourth generation is what I'm really here to talk to you about, and is built, is made of architectures like Extreme I/O, which were built ground up for flash media. What this really means is that the bottleneck is no more the compute even, and the design counters for active controllers would scale out of up to 16 active controllers along with global memory, so that when data services are added on top, like inline deduplication, compression, encryption, and even writable snapshots, there is consistent performance along with significant savings from a data center footprint and power and cooling. And hence this architecture really enables consistently high performance with lower TCO. Extreme I/O as a single business unit of EMC has become the largest and the fastest growing product in the history of EMC, generating over $1.2 billion run rate with 3,000 units shipped and 1,300 new customers. It's enabling newer business outcomes, and hence I encourage you to really look at Gen 4 architectures to enable your all electronic data center going forward. And with this, I believe I've completed my Gen 4 certification. Thank you for watching.